Hey guys, welcome to our homework video for session 5. We've gone through in our lecture video and we've talked about some new tricks and some new tips on the 3D model menu. And we've also added just a little bit more to our sketching capability inside of the 2D sketching menu. So what we're going to do now is we're going to try and put it all together and see can we work through some models at a little bit more of a standard pace. So I'm going to go a little bit quicker on these because I think these parts are actually a lot easier than the ones that we've done in the lecture assignment together. So at this point, you should be able to model these things without too much sweat. I would hope that you'd be able to work through at least these first two pretty easily. And then this third one, there's one tricky thing I'm going to show you on here, but I want to show you guys my workflow and do these at more of a realistic pace instead of going down and slowing down and explaining every little step. Because hopefully you guys are getting some repetition now, and some of this now is starting to be a little more natural as you go through and do this. So first off, before we jump in, what's the homework for this week? We've got 3 models we're going to do together, 6, 10, and 22 out of an older textbook. So I scanned those in. If you want the PDFs, which you're going to have really, you can go into the link here that says homework assignment instructions. And when you click on that, the links for the PDFs are here. That's what I'll be referencing as we go through this. And make sure that the sketches are fully constrained. So they should switch from purple to black as we model them. And then lastly, the other thing you need to do for your homework this week is there's a short online assessment number 3 that kind of goes over some of the things we've talked about. So the info for the quiz will either come from the lecture videos, and it might also, some of it might possibly come from the old textbook we used to use, this Technical Graphics Communication book by Bertolini. So if you need to, you can use this kind of as a reference to look up some stuff. So those are the 4 things you need to do for homework for session 5. 3 of the 4 we're going to go through together. So I'm going to show you guys these 3 models. So let's jump right into it. The first one here is 3-6. They're calling this an S-clip, and it's in millimeters. So as I model these things, I want to try and do them in as few features or as few extrusions or revolves as I can. So when I model this thing, I'm going to start by sketching out this kind of S shape right here, and then I'll go back and cut the holes into it, and at that point, be done. So I'm going to do this in 3 features. I'm going to create the overall shape as sketch 1 and feature 1. The next step is I'm going to cut out one of the sections, that's 2, and the third step is to cut out the other section, that's 3. So let's get into it on this one. This thing is going to be, what is our thickness here? Okay, so they're hiding it down here. So it's 10 millimeter thick SAE 1020 steel. So we know this dimension is 10 all the way through. That's a typical dimension. And then we've got some intermediate dimensions here of 40, 40, and 50. Okay, so let's do that. So I'm going to start a 2D sketch, XY plane, project my geometry, go right into the line tool, draw that shape out. And again, this part, it does not need to be perfect. You just want to get the shape close. There we go. Now you'll notice I didn't do any symmetry on this because this part doesn't really have any. So I just chose an arbitrary point right here to anchor to the origin to keep it from moving around. No really point to try and keep this thing symmetric top to bottom or left to right because it does not exhibit any of those features. Okay. I am going to use an equals constraint because I know my thickness is consistent all the way through. So I'm going to say this line equals this one. And a little trick, this is a little fancy, but I'm going to draw a construction line across here. And I can actually set that construction line equal to these. So there's no actual physical edge in the part there, but I can use that line to change the distance of this middle section. Okay. So hit escape a couple times, and now I think we're ready to dimension pretty much. So I'm going to dimension this line, that's 10. Zoom out, or you can double click your scroll wheel for a zoom extents. And if we check our dimensions, I believe this was 40. I believe this was 40, the overall height. We'll check these when we get done. And I think this was 50, I hope. Let's see how I did. So if we go back, this one I'm not quite sure about if they're trying to, I think they're going to the underside there, so actually I maybe need to increase that. It's not totally clear what they're measuring to, but I think maybe they're measuring to the underside, so I'm going to make this 50. We'll be able to tell when we get done if it's right or not. That actually looks closer. All right, so we'll go finish on that. Now we're going to extrude it out. I am going to do a symmetric extrusion because this part does have symmetry front to back. And our total depth you can see is 40. So let's go with an extrude, choose those profiles. I'm going to go symmetric, and my total distance is going to be 40 millimeters. We'll hit OK. Now we just have to make our cutouts. So let's do another 2D sketch. I'm going to do this one down here first. I'm going to do a little projecting geometry. So hit project geometry. I'm going to choose these 3 edges. That way I can reference them or measure off of them if I need to. And we have a cutout here that is 10 units or 10 millimeters away from both sides, and it has a depth of 15. So I'm going to grab my rectangle tool, draw a quick rectangle in there, and we're just going to dimension off the sides. This is 10. This is 10. And this is 15. There we go. So we'll hit finish. Let's go to extrude, and we're going to choose the cut option right here. That's our only profile, so it selects itself automatically. I am just going to switch this from a distance to the through all option. That way if the part changes, it will cut through everything again. So let's hit OK. We're getting close now. Let's finish this thing up. We'll do one more 2D sketch. This one you can draw either on the top or kind of on the side here. You'll get the same thing either way as long as you model it correctly. So I'm going to draw off the top. I think that's going to be a little bit easier. So let's go with that. I'm going to go onto the top, and we're going to draw a box that is, I don't see a width dimension, there it is, 10 both sides. So basically the same dimensions as what we had down here. So let's draw on the top. I'm going to project that geometry in again, and just again, the reason I'm doing this is it just allows me to lock onto those edges in a sketch, those previous edges in my model. It allows me to dimension off of them, do whatever I need to. So let's dimension. We're going to go 10 here. So that's 10. This dimension is also 10. And then our dimension front to back here is 15. We'll go finish. Now we just need to find out our cut depth, which we have a total of 40 here. Minus the 15 would give us 25 plus 10 more. Again, it's kind of hard to tell what they're measuring to on some of this. I'm going to say it's 35, but let's try it and see what it looks like. Their lines are not totally clear sometimes. That does not look right. So they must be measuring to the other side, different than what I think they're measuring to. So let's, off the top, let's try a depth of 25. That looks more correct. If I put this in isometric and compare it, that looks like what they're indicating. Yep, I'm going to say that's right. So their arrows are a little hard to understand whether they're, and what I'm confused on is whether they're measuring to top or bottom right here. So it's not exactly clear. So let's hit OK. And there we go. That first one's done. So let's save it. And I'm just going to name this figure P3-6. Remember to save your parts with a name that makes sense and break it out into folders. So I make a folder for each session, but file management and 3D modeling is key. People that have bad file management practices are constantly frustrated, especially when they get to assemblies later on. So give it a name that makes sense, that you know what it is. When you go into your file folders and you look through, you can tell what something is just based on the file name. I have so many people that name things just bad file names, and it makes them frustrated, but they don't realize it. So pick a name that makes sense. You'll be glad later. So there's the first one. Let's do the next one now. If we go to new, and go ahead and close that one out, we're done. This one's also metric. This one has no name. So it's basically, it's a block with 3 different heights of sections, 3 holes, and then a rectangular cutout in the front. So we're going to do this in 3 features. So I'm going to show you how to do it in 3 separate features, but I'm going to start by drawing the front here. Okay. So let's go into Inventor, a new metric part, 2D sketch on the front XY plane. Project that geometry in, X and Y. Grab your line tool. Draw out the basic shape of the part. And again, it just needs to be close. There we go. Now let's put some dimensions on there. So our total width is 100. Our highest point is 50. So let's get those in there first. So that's 50. Little trick here. I'm just going to hit escape a couple times, drag this back into shape. Sometimes you just have to adjust it a little bit. Now this is on the bottom 100. Our next dimension, this section's 30, this section's 15, so let's get those heights put in. 30, 15, and now we just need to get the widths. So our top section looks like it is, what, 40? And the other two, I don't really see on here. There we are, 30. So 40, 30, and then this would, you know, by subtraction would also be 30. So 40, 30, and when I dimension this, it yells at me because you can see this one's already set because I've given 2 of the 3 pieces and the total, so I don't need to dimension that. But this is one of those that tricks people. It says 1 dimension needed, but I've got 3 purple lines in here, so what do I need to do? Here's a trick. If it's purple, click it and drag it around, and you'll see everything stays in proportion here, but it's moving around. So what it's looking for is it's not looking for a size, it's looking for a location, and it needs the location of where it lives in 3D space. You can see as I drag this, the whole model's moving around together without really changing. It's just shifting location. So we need to give this thing a home. Either we need to center it right here, or we need to put a dimension in there. I don't like dimensions personally, so I'm going to use a geometric constraint, or I could just, you know, anchor one of the corners, like right here. That works too. So let's see if we can use a symmetry constraint on the sides. If I say this side and this side need to be symmetric around that line, there we go. So that keeps the part centered, okay? And at that point we're good, so let's hit finish. We're going to do an extrusion. Choose your sections. Let's go symmetric, and our total depth on this thing is going to be 50 right here. So I'm just going to put in 50. We'll hit OK. Now we're ready to put some holes in the part. So let's go 2D sketch. Now when I do a 2D sketch, I want to cut all these 3 holes at the same time, so I'm going to be a little clever in the way that I do this. So I'm going to sketch on the highest point, or you could sketch on the bottom of the part also. But I'm going to sketch on the very top of the part, and what that means is I can cut from my sketch plane all the way down through the part at the same time. Now really there's no material here, but it doesn't matter. If I do a through all cut, it's going to cut from the sketch plane all the way down until it hits anything, and then it's going to go through it. So let's do a sketch on the top of the part. I'm going to hit my rotate button on my view cube up here to rotate things around. Let's project the geometry of these sections in. You can see if I click on the face, it brings all 4 of the lines in. I'm going to go ahead and just throw 3 circles in there. You can see I've got an origin dot right there that I'm going to go ahead and use. So I can go there, here, and here. Now if we look at our drawing, these 2 holes are the same size, so I'll use an equals constraint on those. They're both a diameter of 20 millimeters. So let's go equal 1, 2. Dimension this, which will set the size of both of them to 20. The large one, if we look at that, it's a diameter of 30. So let's put a dimension on that one of exactly 30. You can see this one's fully defined now because its center point sits on the origin, and we've defined its size. So its size and location are both set. We've set the size of the small circles, but we need to set their location. Where do they go? Okay. And they are supposed to be in the center of these sections. So, you know, you could use a bunch of geometric constraints and try and make that happen. You could use dimensions. I'm going to use a construction line to make that happen. So I'm going to go to line, turn on my construction line tool, and using my projected edges here, I'm going to go corner to corner on these things. Like that. And now what I can do is where those lines cross, I can use a coincident constraint between the center of the circle and the crossing intersection point of those lines. So let's make this coincident to this. That sets its location. Let's make this coincident to this. There we go. So let's hit finish. Let's go extrude. We're going to zoom in a little bit here with the mouse, choose our 3 circles. We want to switch this from a join option to a cut option. it's going to go down, and instead of just having a distance in there, I want to cut through everything. So let's do a through all on that and hit OK. And there we go. So you can see it cuts from our sketch plane all the way down to the bottom of the part. Very last thing, we just need to put that cutout in the front here. So to do that, you could either sketch on the top plane of the part or on the front face. Based on the way they've dimensioned this thing, they're saying it's a cutout of 20 that's centered, and it's a height of 15. So I'm going to go ahead and sketch on the front plane because that's easier with the dimensions they gave me. So 2D sketch on the front. Let's project in our vertical axis here and our top edge maybe. That allows me to lock onto those. So I'm just going to click on that top line, draw a rectangle. I'm going to go ahead and do a symmetry constraint between these two sides and the center. That keeps my rectangle centered up. Now I can dimension that to be 20 wide, and my height is 15, I think, if I got those right. Yep. So we're good there. Let's hit finish. We're going to extrude a cut now. So choose your two sections, switch to a cut operation, and how do we decide where to go to? So you could key in a distance, right? Just find a number that works, like 25, as long as it cuts in far enough. If you want to do this with a little bit better design intent, we can try the 2 option and see if we can cut to the inside face of this circle. What that will do is if the circle changes size or if that hole changes size, it will make sure that our cut always goes until it hits that circle. So that's a little bit cleaner design intent than if I do this. That depth option, you know, if you just key in a random depth of like 20, the problem with that is if this hole gets really little, your cut may not make it far enough to clean up the edges. So from a design intent standpoint, to make this part update nicer, I'm going to say 2 and pick that face. Okay, hit OK, and we are done with that one. So that's a quick run through on that part. Let's save this thing. This is figure P3-10. Save that. You guys can upload that one now if you're done. And then very last, we're going to look at 3-22, which is this one. Now, when I do this in class, I usually give people this dimension right here because it's a little tricky as to how you get that, and you'll kind of see why as we go through. But I may show you guys the sketch process on getting this without that dimension. So it makes it a little bit easier if you have that dimension. But let's go ahead and do our last new part. This one is inches. So let's do English, standard inch, 2D sketch. I'm going to start by sketching the side profile right here. So I'm going to draw that on the YZ plane, just so it kind of ends up the way they've shown it here. So I'm going to pick that, project in your axis. Come on. Oh, it's the Z, duh, because I switched axes. Okay, so XZ in this case, or YZ, sorry. Now I'm going to grab the line tool. I'm going to start at this origin point right here and go over. And when I draw this, I'm just going to make everything a sharp corner for right now, except for this guy. I'll show you what to do with that. But I'm going to work my way over and up, just doing sharp corners on everything. Like that. Grab that line tool, straight up. Now I'm going to grab my circle tool and just draw that in really big, okay? So you can see the center point for this circle lines up with the front edge and the top edge of the part. That's what they're trying to show you right here. So you have a perfect fourth of a circle. So to do that, what I'm going to do, let's shrink this down just a little bit so it'll fit in there. But I'm going to go to a coincident constraint, and I'm going to say let's make the center point coincident with the top, and let's make the center point coincident with the side right here. What that does now is it lines up the center point perfectly with the top and with the front of the part. And now I can grab my extend tool and extend those lines through where they hit, or you might need to trim them off depending on the size of your sketch. I am going to grab the trim tool and trim the outside of this circle off so I have just the piece in the middle there. So we're getting kind of close to the shape there. I am going to bring this top section up a little bit so it looks a little closer. Let's put some dimensions on here. Now, one thing that makes this a little bit tricky is when you work in fractional inches, things get rounded off. Like 3.88 is actually 3 7/8, but they've rounded off to 2 decimal places. This is actually 2.375, which again, this is another reason why the US customary system is inferior. But if you look up a fraction to decimal chart, this is really handy to have if you're working in inches ever. Most designers have one of these things printed out somewhere. You know, I've got one in my office at work. I've got one in the top of my toolbox, like for measuring drill bits. It's just really handy to know from a fraction standpoint. You know, if you pick up a 13/32 drill bit, what is that fractionally or decimally? You can convert back and forth. Or if you think, okay, well, I need a drill bit that's about 0.8. What do I pick? Well, now you can look in here and say, okay, well, a 51/64 is a little bit too small. A 13/16 is a little bit too big. So you could kind of go in between there maybe, or choose one. So this conversion chart's really handy. But if you look at our drawing, there's all kinds of stuff that they've rounded off on eighths. Like this, they would round off to 0.13. This would round off to 0.38. When I told you 7/8 rounds off to 0.88. Most designers have used these enough where they've at least memorized the 8ths and 16ths, if not the 32nds. But memorizing at least the outside of this chart will make your life a lot easier if you're working in inches. If you understand the 16ths and 8ths, when you see a number, you immediately know what it is, and it's just through repetition. But so going back here, let's dimension this thing. And I'm going to use the true values for these things because we want to try and get it where everything works out. So the width of this thing, I'm going to make 3.875. So if I dimension from this line to this one, 3.875. Let's zoom out. Let's figure out this curve. This is exactly 2. So let's dimension this curve to be 2. That's going to help a lot. Our total height, if we look at that, is going to be 2.5. So let's dimension from top to bottom. That's 2.5. This little section on the back is, where is it at? Okay, well, we can do it this way. We can look at the top. We know this is 1. So let's do that. If we dimension this thing to be 1 inch, that sort of gets us there a different way. Now we need the height of this section, which is our 1.25. And then what else are we missing? Well, let's put that in first and see what we end up with. So this is 1.25. And if I hit escape, it needs something here. Okay, somehow we've lost our constraint there. So probably when I trimmed, it broke that constraint. So I'm going to go back and fix that constraint where this line needs to be coincident with the center point. That'll fix that. Okay. So there's the basis for our part. Let's go ahead and put the fillet on the back and put the hole in the middle, and we're getting pretty close. So this curve, if you look at this, this is a radius of 0.625, I think. Yeah. If you look at this dimension right here, which really should be 0.63, they've left the decimal place off. So it's a rounded off version that they've written incorrectly of 5/8. Some of these drawings are bad. So basically this distance from here to here is 5/8 of an inch. So I know that this curve is 5/8. So let's go fillet, 0.625, choose your lines, and there's that. And now we've got our circle. Make sure you don't accidentally put your circle at the center point of the fillet. They're 2 different center points. So this is a 1/2 inch diameter circle that is 1 1/8 up. So let's do our circle, dimension it, 0.5 diameter. The distance down to the bottom is 1.125. And now here's where we can use a feature of Inventor pretty nicely. If I measure off the side over here, I can do 0.875 plus 0.625 from my fraction to decimal chart. So I'm going to dimension from here to here. 0.875 plus 0.625, and you can let Inventor do the math where you don't have to have a calculator handy even. You can just type it right into the dimension menu in Inventor. There we go. So our sketch is switched from purple to black. Everything's fully constrained. Let's hit finish sketch and extrude this thing. Choose your profile. I'm going to go symmetric. That's important on this one. You're going to see why in the last step here. And our total depth is 2 3/8 or 2.375. Hit OK. Now we just have a couple of cutouts to put in here. Let's do the one on the top first because I think it's a little bit easier. And I'm going to assume that this width is the same for both of them. They don't really say, but they put these lines in here, I guess, which were made to assume that the width of this cutout is the same as the one at the top by these two lines, or curves, I guess, really. So this one is 0.69 tall by 0.75 wide. So I'm going to rotate around to the back and sketch on this face. Let's project that geometry in. Draw in a rectangle. Our height's going to be 0.69 from our dimensions. Our width is, oops, if I go from here to here, your width is 0.75. Now we need to center the thing. So on this, you know, if you wanted to, there's nothing really wrong with putting this 0.75 in there. You could do it that way. That's okay because they gave us that dimension. If you're absolutely insistent on using a geometric constraint, you could make your own center line in here based off the center of this top line. You could just draw a construction line in there like that. That won't be part of your final sketch. An inventor shouldn't pick up on it when you extrude. But what you can do is use that for a symmetric constraint. Oh, it doesn't like that. Okay. What have I done that it does not like? Let's move this over. Try it again. I think I anchored it to this line instead of this one, which really it shouldn't matter. But oh, what we could do instead, let's try this. These both have center points. We could try and do a coincident constraint on the center point of this line and the center point of the top projected line. So let's lock this point to this one. There we go. No construction lines needed even. That's even cleaner. There we go. So that avoids you having to do the dimensions to center the thing. Hit finish, extrude, choose your sketch. Let's switch our operation to cut. And I'm going to use the to option again. So I'm going to say cut to this curved face. That makes sure it cuts through and stops wherever it hits at. Hit OK. And now we're down to the tricky one. So I'm going to show you how to do this one based off the information they originally gave you without the dimension that I wrote in here. So the trick to doing this is you have to know how to sketch on this plane that's in the middle right here. And the other trick is that when you modeled this, you had to think forward far enough when you did this extrusion to do a mid-plane extrusion. Okay, so what I mean is you had to pick this symmetric option. If you didn't choose that, you won't be able to do it this way. So when I sketch, instead of sketching on the bottom face or the front face, like a lot of people would be tricked into, I'm going to sketch on this plane right here. Okay, so I'm actually in the middle of the part now working out. I'm going to hit F7 to slice my graphics on the keyboard. Remember that trims back to wherever you're drawing at, wherever your sketch plane is. Now I'm going to use that project geometry tool and choose this curve, this line, and this line. Okay, now the trick on this is, and the reason I'm doing all this, is the only information they gave us for this cutout is the width and the height of the back, but they don't tell us how deep the cut is. So the problem is when you draw this, if you draw it from the front and try to extrude it, you don't know what this dimension is unless somebody gives it to you. And I gave it to my students in the past, so I wrote it in here just because I thought this was a little tricky. But you can do it parametrically without knowing this number, just based off these two. So here's what we do. We're going to draw in a rectangle. So I'm going to go to this corner and then just draw it anchored to this curve, like that. So what I'm going to do is dimension the height of this line now from the inside of the part. I want that to be 0.625, and it's fully constrained. So you can see that the size of this projected curve and the location of that endpoint control the depth of the cut, right? It's 0.696, but it's 0.696 because that's where this point lies on the curve with this height. That's pretty tricky for somebody that's only a few weeks into this. So that's why A, I do these videos and show you guys this stuff, but B, I want to show you you're able to do this without knowing that magic number. parametrically you can do it, but that's kind of a reach for people at this point, right? Until you get into this for a month or two, you may not pick up on that. But the trick is to A, be good enough at parametric or geometric constraints to make that happen. And B, you got to kind of think of it in advance to think about where your midplane is going to be in your sketch and how you can dimension that and constrain it. So that's an intermediate level skill probably. So let's hit finish now. You can see my sketch is inside here. I'm going to go extrude. You can really choose both of these, it doesn't matter, but we're going to go to a cut. I'm going to go to a midplane cut or a symmetric cut, and our distance is going to be 0.75. There we go. And hit OK. So what a lot of people want to know is, well, why can't I just draw on the bottom, right? Because it's just a rectangle if I do it from the bottom, and I could just cut it up. You could normally, but the way they dimensioned it, they sort of shot you in the foot because you don't know the depth of the rectangle. You know the width, but you don't know the depth, and you can't draw on a curved surface. So somebody sat down and really thought through this and almost kind of tried to pick on you and thought, okay, well, if I dimension this way, it's going to be really easy. But if I leave that dimension out and dimension it this way, it's going to be hard, and they're going to have to know about geometric sketching and parametric sketching and how to get these numbers in there and have it work itself out based upon the height and the location of that curve. So that's pretty tricky, actually. Someone sat down and thought through this a long time to try and force you into doing that. So, but hopefully it works or helps a little bit, you know, watching me work through it. So that's our last one. It's fully constrained, 3 extrusions. Everything looks good. So let's save this thing. Figure P3-22 in my session 5 folder. Hit save. You guys can upload that thing now. And again, I think these are a little bit easier than the ones we did in the, maybe not this one, but the first 2 are probably easier than what we did in the lecture video together. So hopefully this helps you at a little bit quicker pace and just some different parts through repetition to see how other people would do them, other people being me. So remember, for your last piece of your homework, you need to do online assessment number 3, which is going to come from the lecture notes and also our Bertolini PDF textbook up here that I refer to occasionally. So that's it for session 5. If you watched the lecture video, you've gone through this homework assignment video, congratulations, you made it to the end of yet another session. So good luck. Hope it went well. I hope you learned something, and I will see you guys in the next video. Bye.